Anything that wants to scale on Solana, on the L1, eventually will hit limits or constraints when they use just like pure on-chain state for everything. You have apps like Drip, but also protocols like, Helium, HiveMapper, who want to serve a lot of users, and they don't want to build their own, L2, L3 or whatever. They want to use the L1. Compression is a great way to do that, right? So to go on the L1 and benefit from the L1 while still scaling to a lot of users.
This episode is brought to you by Helium Mobile. They've created a crypto-native phone plan for unlimited talk, text, and data for just $20 a month. We'll chat more about them later in the show. Before we get moving on today's episode, just a quick disclaimer. The views expressed on this podcast by either myself, my co-host, or any guests are their personal views and do not represent the views of any associated organization. Nothing in the episode should be construed or relied upon as financial, technical, tax, legal, or any other advice. Okay, let's jump into the episode. All right, everyone, welcome back to another episode of Lightspeed. Mert and I are joined today by Swen from Light Protocol. Swen, thanks for coming on. You guys recently released ZK compression. It was actually 7 days ago to the day we're recording this on the 28th of June, and it was the talk of the town. Some people were arguing over semantics, as we love to do in this industry, while a whole nother cohort of people were excited about this and what it enables to build. So I want to jump into ZK compression and talk about what it is, what led you to building it, and ultimately, some potential use case unlocks for this technology. But before we do all that, I think a good starting point here is just going to be, your background and what led you to what led you to building Light Protocol, and ultimately what the purpose of a Light Protocol is.
It started pretty long time ago, summer 2021. My now co-founder, his name is Joe, and at that time he was working on this sort of like side project of his. He just finished his master thesis on. Back then, he wrote it on private voting using the blockchain. And so he found Solana in the process of that. And he was like, oh, this is cheap. It's actually much cheaper than Ethereum. So you could actually build private voting on Solana. So that was the whole starting point of this. And so it started with privacy, and it always had this element of ZK. It was just this sort of like natural interest of my co-founder, who, by the way, we've been longtime friends since childhood. So it's just very natural progression there. When we met up in Berlin 2021 and chatting about stuff, and he was like, oh, I'm working on this thing. It's on Solana. Do you want to help me out, writing some Rust code? And I was like, sure, why not? My personal background was for a couple of years before that, just been working on different companies, projects, trying to, and it was all about too, so like trying to sell, SaaS to small and medium-sized businesses in Berlin. So very different space. And I was like, sure, why the hell not? This sounds super interesting. Solana was just, was pretty hot at that time, actually, summer 21. And so we worked on this thing, and we got pre-seed funding. We're like, okay, let's do this full time. Let's build the first ZK verification on Solana on chain. Solana didn't have any of that before early 2022, when we sort of released this thing on DevNet and later mainnet. I think that was April 2022. And the whole thesis here was that Solana wants to reach mainstream adoption, this typical thing, and then you have to, okay, so you need privacy, right? Like if you do payments on chain, there's no way you're not going to have any encryption whatsoever. So it was like this super like left curve thesis in a way, because we were like, okay, this obviously has to be true, and then like if Solana is good enough in scaling to the masses, this is obviously the place to build it. Right? Compared to any of these other chains where first have to sort of build scaling first. And I'll come back to that, because it's sort of like full circle now with ZK compression, which is more of a scaling solution for Solana. And we built the first ZK verification. It was Grow 16 proofs, snarks on chain, in a pretty primitive way, and just improved on that. And then fast forward during the bear market, we sort of focused on, so basically what we said was, okay, so there's a bear market, users are gone, liquidity is gone, there's nothing really much happening, so just like ran through the bear and build cool things. And that again was pretty much like the left curve thesis of ours, is that, okay, it's going to be cool, let's build cool stuff, it will be important in the future. And what we said was, well, actually, we figured out a couple of things with regards to privacy in the process of shipping the first version, second version. And that was that privacy is incredibly hard to solve on a blockchain. Not so much technically, like you can come up with different solutions. Blockchains have done it before, Zcash has done it before, Monero has done it before. But what's much more important with any product, probably, I think Mert would agree with me there, is like distribution, right? It's you have to find a way to get to customer, and usually the best way to do is do something like build a product that users want. And so with privacy, the problem is it's very intangible. People sort of need it, but they're not really aware of it. And you do have like a small group of people who are actually very aware that they need it, but they're not necessarily the best customers, just because they're a small group, or they want to be private. So you're not really you have no real chance to talk to them because they're not they're not out there in the open. So there's a couple of really hard problems and headwinds that you get when you want to build for privacy, especially so on a blockchain, which is like this very constrained environment to build anything. And so fast forward to end of 2023, and I'll give it a little bit more context, which is like we said, okay, so let's make ZK verification on Solana really, really powerful, really efficient. So we built a bunch of syscalls into Solana runtime. Took a long time. We started that process in 2022, and now sort of the last syscalls are going live on mainnet. So it's been a sort of this process of like working on fundamental primitives that would later enable us to use ZK, which is like, again, the thesis was like ZK is really important, privacy is really important. Let's make sure that Solana is sort of in a really good position now and in the future to support these sort of problem sets and us to solve them. And and then in 2023, what we had built then was like this private smart contract execution thing, which is pretty cool actually, because it's like encryption, but it's also sort of like generalized VM in a sense where you do have this sort of notion of stateless verification. So you have some like state transition function that is in an off-chain environment. In our case, it's like, for instance, a private token transfer or a private order book or escrow or whatnot. And you just verify that on chain, and then you apply the state changes onto the ledger. The state changes are encrypted, and then the user fetches the state changes from the ledger, and does a new transaction. Decrypts them, does a new transaction with other users. And so this thing, what we had built was ironically something that looks very similar to now ZK compression, and I'll get to that. But it inherently was for like private state transitions. And then at the end of 2023, I chatted a little bit with Noah from Helium, head of protocol engineering there, and he was like, "This is really cool. I like the sort of what we could use privacy for, voting, etc. But actually, he was like, what I need cheaper state, and like SolPrice had just like this nice run." A run up, and people started complaining about the price of state just being more expensive on Sol now and getting more expensive over time. And obviously, as Sol goes up, and we had this sort of like epiphany in a little bit. We were like, okay, so no one wants to use our tech, but for something else that we had not really thought about and intended it for. And I think in that process, we talked to a couple of other people. We figured out that Solana Foundation was also interested in seeing the ecosystem build a solution for better state compression, which is essentially what ZK compression does. And then we chatted with the guys at Helios and his team, and had a pretty quick pivot at that time where we were like, okay, let's drop the zero knowledge private transactions part and just focus on the very raw core of that, which is just stateless verification of state, and using very simple, small zero knowledge proofs, validity proofs, if you will. And that's what ZK compression is. That's what we've been shipping for the last 5-6 months, I think. And just as you said, last week, Friday, we announced that on testnet.
Decentralized physical infrastructure networks are a massive point of emphasis in the crypto industry today, and Helium Mobile is a fantastic example of a business that is leveraging this distribution approach. Like any network, there's a supply and a demand side. So the supply comes from hotspot deployers, while the demand comes from phone plan subscribers. Together, they create and power a decentralized wireless network that provides expanded connectivity and amazingly priced phone plans. But let's zoom in on how it works for deployers. So you get this device and you set up this hotspot, and anytime a Helium Mobile phone user is near your device, they will send and receive data through the internet using your device instead of their cellular network. The cool thing here is that you earn mobile token rewards for providing this service based on the amount of data routed by your device and how much coverage you're creating. There's also what are called boosted locations, which are directing rewards to the targeted areas that actually help individuals and businesses deploy these devices in the proper areas where coverage is actually needed based on where subscribers are. Currently, that's in LA and Miami, but soon to be coming to New York City. Again, by creating coverage, you're helping build a better network together while earning mobile token rewards. If providing the service is something that's up your alley, head over to hellohelium.com/hotspot to get 15% off your indoor or outdoor Helium mobile hotspot using the code Lightspeed Hotspot. That is all caps, no space. Lightspeed Hotspot. And we'll be sure to put that link in the show notes.
Yeah, that's great context. I'll actually provide some more context from maybe the other side of this, which is that, so about a year ago, maybe over that now actually, there was NFT compression that was released. And at the time, it was very hand wavy, I want to say. And it was kind of just this project where Austin, who was at Metaplex, but then now is at Anagram, he had built like this proof of concept reference implementation along with Solana Foundation. And at first, we were trying to solve the problem of like, how do you mint so many NFTs at scale? And it turned out that Helium would migrate and that they actually needed this for launch. And then I saw that, or like Helium saw that. And then we looked kind of at the market, and it was still pretty unproven. And I kind of just pulled aside Nick, who was my co-founder, and I was like, okay, just stop everything you're doing and focus only on shipping NFT compression to mainnet, along with like everybody else on the project. And then, so we like hustled super hard to get that live. And then Helium was able to migrate. And
clip it. That was beautiful.
And a bunch of teams and whatnot followed on after. But then we noticed, like, wait a minute, this is only on NFTs right now, but it should actually be, because like everybody was having the same problem with stake costs, it should actually probably be generalized. And we were going to do that. And then we were like, and then it starts to get super complex actually when you start getting into like PDAs and kind of Solana specific nuances. And then at the same time, Solana Foundation, we were talking to John Wong, and he also had the same thoughts. And he, I think, put out like a request, and we were going to submit to it. And then we were like, wait a minute, Light is also submitting into it, and they're much better at this. So we should just kind of combine forces here, and then they can do the stuff we're not good at, and then we can just do what we're good at, which is infra. And so, yeah, I guess that was like roughly 6 months ago. We actually, I think both the teams shipped pretty fast on this. So yeah, that's kind of the additional context that it kind of like evolved from NFT compression. And then because NFT compression is used by a lot of teams today, like Drip, for example, used to mint millions of NFTs. Okay, so with that context set, I guess do you want to, Swen, just describe maybe on two levels, one on a non-technical level and one on a technical level, let's say for researchers or developers, how compression actually works?
Yeah, sure. Okay, I'll start with compression, and then I'll elaborate a little bit on the ZK part of it in the naming. So on a high level, it's really what you're doing when you're building an application on Solana, and you're a developer and you want to compress your state, you basically shrink or compress many account states into one. And I'll give context on what an account is, right? In Solana, it's just like a bucket of state. And in Solana, basically everything is an account. And you can think of them as like these buckets of state, which is just like bytes, right? And these buckets have ownership and LAN ports attached to them. And when you use compression, essentially what it does, it just like compresses many of these different accounts into one. And it does that by basically taking this like long string of many accounts and account states and hashes them recursively, like the different parts together, so that in the end you have a very small string. In fact, just like 32 bytes, which is called sort of the state root. And you place that in the on-chain account, and then you can basically put this long string of accounts somewhere else. You don't have to store it in the on-chain account. You can, for instance, store it on the Solana ledger, which is just the ledger space is much cheaper than the on-chain space. And on the technical level, Merkle trees are pretty cool. And you can use binary Merkle trees to get to this like hashing structure that I just described. And then you store the root on chain. You store the actual underlying account state on the ledger. And then when you do a transaction, you just specify which accounts you want to read or write to. And you send them on chain in your transaction. You need to somehow prove that the underlying account state corresponds to this like root hash that is on chain. And that's essentially what you have to prove. And then you can go ahead and like apply your custom state transition function in your program. So that's essentially, I guess, the TLDR.
One of the pieces I want to unpack there is the idea that state is more expensive than like the ledger space. Can you elaborate on why that is?
Yeah, for sure. So on Solana, each validator has to load the different accounts into, what you say, RAM, which is just like this more expensive fast access space. Whereas the ledger, and Mer probably knows more about this, but like the ledger is, as far as I know, not necessarily, the validator doesn't really have to keep track of the whole ledger. Whereas they need to with the current account states. So that's basically it. What the ledger, the ledger history basically is just a place where it can be stored in like a Postgres database, but like it basically makes sure that the state has been published on chain in some on chain transaction, right? So that's where when it's being emitted, it's like emitted onto the ledger history through some logs or whatnot.
I can maybe follow on that. So just to sum it all up, on Solana, unlike Ethereum, the data capsules, like where you store data, so for example, your name, let's say, is different than the contract itself. These are decoupled. And so if you want to, let's say, mint 10,000 NFTs, what you need to do is you need to tell Solana, allocate me 10,000 different accounts. But obviously, you need to pay for those accounts because they are stored by the validator, right? And if there weren't a good enough cost for it, you could just allocate billions of accounts and overload the validators. And so there needs to be a cost to it, which is called rent. And the accounts are super important because that's where the state is stored. And essentially, Solana's only job is to ensure that state n maps to state n plus one, right? It's a state machine. You just go from state, and then you have to ensure the validity of that state. You do not need the ledger, which is, maybe you can colloquially refer to it as transaction history plus historical blocks for the state transition, right? It's because there's a hash and people have already voted on that. And so all the validator actually needs is the current state of everything, which is all in accounts, which is why it's more expensive. So on a Solana node, the transaction history is stored on the validator's, let's say, fast memory for up to 2 or 3 epochs, which could be up to like 3 days. And once that happens, it gets pruned, and then it gets sent to an archival node. And then the archival nodes are what keep track of the state. So it's actually quite similar to Ethereum in that sense, right? Because Ethereum has the call data, which like you don't get all of that unless the entire thing is an archival node. So that's, and obviously since not every single validator needs to store the archival nodes, then you don't have to pay as much for the replication factor.
Okay, and to try to make a parallel here, which I completely understand that it's not always possible, so please do correct me if this doesn't make sense. But if I tried to make a parallel to Ethereum, is the idea that like storing the transaction data, if you will, or that's more like the state data, storing that in the ledger, is that like comparable to storing data in like as call data in an Ethereum transaction? Is it similar there?
Yeah, I mean, I've never really programmed on Ethereum, but yeah, from my understanding, that is what it is.
Yeah, it's just about identical. I mean, I also don't know the very, very specific nuances, but for example, on Ethereum, right, if you want to get all the token holdings for an address on Ethereum, there is no actual RPC call that exposes that. What you need to do is you need to go back in history since Genesis, which you need an archival node for, and then accumulate that state. Hence why it's called a stateless accumulator, right? Because that is exactly what you're also doing on Solana. You're going through the ledger, and then the indexers, for example, what we released with Light and ZK, it's the Photon Indexer, and all it does is it watches the ledger, accumulates that state, and then exposes it in a single call.
That makes a ton of sense. Okay, and so if I was to like try to TLDR this, the last 5 to 10 minutes of this discussion, it's basically on Solana. Pretty much any piece of state is going to get its own account or its own address, and because of that, the validators actually have to store this account list in every active account in their RAM or their fast access memory, and that costs money to the validator, and therefore it's passed back to the user to try to limit the amount of state bloat. In the form of rent, right? So there's like a minimum deposit. I don't know the number off the top of my head to actually have an active piece of state or an active account. So for, I guess, a simple example of this is like a token, let's say the JTO token. If I were to like purchase tokens, I would get a program derived account or a PDA from the JTO token contract that is like my ownership of that token, for example. And so it's not just like, first, that's a little bit different than Ethereum. So I just kind of wanted to highlight that difference. And because of this idea, you can enable unique unlocks on Solana, such as parallelization, for example. And so I think that's like important context to the listener, just to understand like Solana has a different construction than Ethereum. And because of that, state gets expensive. And so it's a really interesting to kind of see, Swen, your pivot of saying like, okay, like privacy was the priority, but then in that journey, you kind of notice that state is expensive and there's people hitting these limits. And if we can find a way to simplify that, that there feels like a material unlock here. But before we jump into the unlocks, Mert, I kind of wanted to expand on, I think the indexer was called Photon, right? So selfishly from a data analyst point of view, how easy is it to interact with this new indexer, if you will?
Yeah, so we made sure that running it locally was like a very high priority. So you can run it locally on your own, and the DevOps and all that is all taken care of for you. You'll need access to a Geyser node, which again, it's like $300 per month from like a Terra Switch or Latitude. And then that's pretty much it. And then obviously since, people, that's a nice to have, and because you can run your own node, whatever. And by the way, it doesn't, people will call it hardware costs, but like these nodes, so there's multiple types of nodes on Solana, but these are the ones that don't have to vote. And so you don't have to worry about like validator profitability or voting costs and all that. It's just a node that watches the chain and then just has that state. And so you just couple that with this, it's an open source repo, and then you can kind of get up and running. And then obviously we have a hosted version where, similar to NFT compression, it's called the DAS API, Digital Asset Standard, where we perform a lot of optimizations for different types of queries, complex joins, enhancements with metadata and all that stuff for like something a bit more premium and enterprise ready. So yeah. And then kind of going back to the actual state thing, one of the reasons this is important is and I referenced this in my kind of launch tweet, which was kind of Tolly's screenshot, which he's like, if this works, it'll change the fabric of the universe. And one of the reasons is because what you can do, I mean, this is an idea, it's not really fleshed out, is I think something like, I'm not sure if it's 70 or 80% of Solana state is actually cold, meaning it's not actually accessed very often, because certain programs like Jupyter, for example, are obviously hotspots, but not everything that's being stored by validators is necessarily accessed too much. And so what you can do is you can actually compress the state that is cold, which is the majority of it, and then, maybe kind of decompress on demand if you even have to, or maybe you kind of just use this primitive. And so that what that means is you can actually make it's a good proof of concept for later work on Solana core for actually helping kind of solve the state growth problem. And, this will also include maybe new pricing for rent and storage as well. But and this is kind of why I get a little angry, let's say, when people in certain marketing departments are like, well, you can only parallelize innovation and modular ecosystems. It's like, that's clearly not true, because we just did it. And if it works well, then it'll be enshrined, right? And so just to say there's direct counter evidence of that argument.
Is that the goal here, to kind of get this piece of technology proven, iterated on, hardened, and then enshrined?
Yeah, so ostensibly, I think that all, good tech that solves a problem for the L1 should, in the long term, will be enshrined or should be enshrined in some way or another. And I think that, that's the way how, you have this sort of like layer of permissionless innovation on top. And I think that's actually some of the strong things that with sort of the, modular scaling approach that sort of a lot of people in the ETH space are taking, is you have really like permissionless innovation, because like people can just like experiment quickly on their stuff without having to necessarily wait on core protocol changes. What I think though is, and very much of the same opinion there as Merritt and what he just said, is what you actually need is you need both. You need core protocol innovation, and you need the core protocol to ship fast enough. And I'm actually, that's something that I think is going to be an ongoing challenge for Solana as it sort of grows as a network and matures. But you have to sort of keep protocol changes up. But at the same time, you need to have an active ecosystem of infrastructure builders as well, who improve the protocol, improve the network. So first on this like application layer, and then if it works, why not enshrine it? There's another thing. There's like a third thing that ostensibly I want to quickly highlight. That's sort of like for us as Light, sort of what's the point in doing all this? Is it's not really a sort of like this standalone tool that we're building for developers, and we just like go on to the next thing. Actually, if you zoom out, what this allows is what it actually does is it provides Merkleized state to Solana. So Solana doesn't, in the core protocol, like state is not Merkleized. And there's very good reasons for that. It's because Merkleization of state, as you see in Ethereum, all state and state changes are Merkleized. The problem with that is that this Merkleization process, this hashing process, is extremely slow compared to if the block times and what the Solana validator needs to do when they execute stuff. But there's a really good things that you can do with Merkleized state, because basically if you have this state in this like Merkle tree structure, every state and state change in state at a moment in time becomes a commitment that you can very easily verify, via this hashing or some other proofs, or other proof constructs, and it sort of opens up once you have state that is Merkleized, it opens up this like whole design space of applications and other protocols to utilize that to like have math-based verification of state changes that are otherwise sort of relatively speaking off chain. Like in ETH, you see a lot of each Rollup on ETH or L2 or L3 or whatnot on ETH, sort of maintains a state root on Ethereum mainnet. And Solana doesn't have that currently, but basically what ZK compression does is it now places a primitive on the L1 on Solana L1 that allows for these kind of like constructs to sort of plug into TL1 directly. And I think that's more sort of like a long-term thing. And then, you can think of it as like, now you have not only on-chain programs that can do like on-chain state transitions and like define their state transition function on-chain, validate it on-chain, apply state changes on-chain. But now you can have programs and applications that define parts of their state transition function off-chain, right? And then proof the verification, proof the state transition, verify it on-chain in their Solana program, and then apply the state changes via these state roots on a Solana, drop the state on a Solana ledger, and I think that's pretty cool because this primitive is something that hasn't existed before, and so long term, I'm very optimistic about what that enables. One specific thing, and is like coming back to where we started, right? Is one of these like alternative VMs, if you will, that you can define off chain is. In a classic example of that is, encryption. So if you want to have, you want to verify encrypted state transitions on a blockchain, you can't really do that on chain so easily. So you want to, describe that in an off-chain state transition function, verified on chain, and then apply the state changes on chain. So you have now these like, sort of this permissionless space for alternative VMs and so on to plug into it, and I think that's quite powerful. Yep.
My friends, big news. Blockworks is hosting Permissionless III in Salt Lake City this year, so we're heading west for 3 days starting October 9th. Permissionless is our industry's premier DeFi event that brings together crypto natives from all over the globe. I've personally been the last 2 years and can honestly say that the attendees are incredible. It's people who actually care about crypto. We'll also have more than 200 industry titans speaking at the event, and this includes builders like Lucas Bruder from Jito Labs and Brian Pellegrino from Layer Zero, or investors like Kyle Samani and Joe McCann, and even elected officials like Representative Tom Emmer, who's fighting the good fight in Washington. And it's narrative season, so we're going to be covering the 7 hottest themes in crypto. This includes things like modularity and restaking, or Bitcoin and L2s, and even AI and crypto. The goal is to keep you up to speed on major developments in the industry. Ticket prices will be structurally increasing over time, so get your ticket today. For my Lightspeed family, I got you. We're going to use code Lightspeed10 in all caps, no space, for 10% off your ticket. All right, everyone. I look forward to seeing you at Permissionless III, and let's get back to the show. Okay, so yeah, that's really interesting to start unpacking some of the use cases, right? So that's an interesting one with the idea of having encrypted transactions, and I like how that kind of ties nicely to your original thesis with Light, which was privacy related. What else do you look at the market and say, okay, this use case, the solution of ZK compression is perfect for this use case? I saw the airdrop example in the docs as well, but I'm just curious what else you've thought of that it really seems to plug a hole for some developers.
To zoom out, right? Anything that wants to scale on Solana on the L1 eventually will hit limits or constraints when they use just like pure on-chain state for everything. Just because, so to give you a specific example, I think right now a single token account costs like a little bit less than $1 to instantiate, and it's like this, rent is it's not actually rent; it's more like a upfront bond that you put on, that you pay, and then you can claim it back later when you close the account. But that's the amount that you pay for a single account. Now imagine you actually want to scale to larger user bases and like instantiate an account for each of them. The cost of that is quite constraining. So as I mentioned previously, you have apps like Drip, but also protocols like, Helium, HiveMapper, who want to serve a lot of users, and they don't want to build their own, L2, L3 or whatever. They want to use the L1, and so they need this like sort of compression is a great way to do that, right? So to go on the L1 and benefit from the L1 while still scaling to a lot of users.
Do you forfeit any composability with the L1 when using compressed state?
So there's definitely nuance to this, but the way that we've built it, it inherits the basic principles of like Solana, right? So like each state tree, if you will, which can have one or many accounts that you want to access in a transaction, is a single account, and so you can like define your accounts that you want to compose with in a transaction. And the nice thing about the system is that you can also describe your state transition function for your custom caller program completely on chain, right? So you can fully compose with, all the other programs. You can use the, Anchor framework to build your programs, and you can mix and match basically. Some of your accounts that you want to create or just, close or update can be compressed, and some of them can be uncompressed. And then you can also, sort of switch between compressed and uncompressed. So that's pretty easy. And then, there's some nuances, as I said. One nuance is that this whole compression involves a lot of hashing. It involves a snark, sort of ZKP verification. And so that costs compute. And, if blocks are full on Solana, there's some prioritization of like by compute use and like priority fees paid. And so there's this like nuance that first you're using more compute, you're passing more data on chain, obviously, because you're passing sort of ledger data onto the chain. And so there's these sort of like nuances there that you can consider for your specific use case.
One thing that comes to my mind here as an interesting user of this are definitely deep in networks. I think my basic understanding of Hive Mapper is, they have these cameras, they get people to put them in their cars. Those cars go out and map different areas in the world. And for doing that action of mapping roads, they receive token rewards. And I think on some like programmatic basis, Hive Mapper pushes those tokens to the user. And so in this example, that would be Hive Mapper, the protocol, paying for those token accounts, paying for the state of those token accounts. So to me, this seems like an exciting user because there's some like consistent reoccurring action of distributing tokens to users that becomes cheaper when using this. Is that does that make sense or does that add up to you, Mert?
Yeah, that's pretty much it. Yeah. I mean, like the way you can think about the account construct on Solana is like you have a bank account and you obviously do not store all your currencies in the same accounts, right? You have a checking account, maybe a US checking account or whatever foreign currency, you have a savings account, all this stuff. And each one of those are different account types, all under your root kind of, let's say, public key. And so with something like Hive Mapper, probably an easier example is just an airdrop, right? To airdrop to 10,000 people, let's say, that's 10,000 token accounts. And with this, it's not that, right? You can also get creative and batch stuff and really improve both cost and speed and like also UX, because people don't have to do this weird game of having to go and claim everything so that they pay for their own costs and stuff like that, which sometimes might be done for tax purposes, but it's anything. So facilitating kind of large scale payments, payouts, rewards are a pretty no-brainer case for this.
Super interesting there. And then just continuing this example, Hive Mapper already has like a token account. And so for them, they existed before ZK compression was a thing. And now maybe they're super fired up and want to leverage this. I have no idea. I'm just, using this as an example. Is it possible for them to like switch over to this, even though the Helium token already has an account that's like that exists?
Yeah, I mean, you'd have to adapt your smart contract logic. So it's a new primitive. You have to include that. You have to update it or deploy a new contract and then sort of migrate your users over with some, like button click or whatnot. But yeah, you can do that, right? So you can like close your, this is what you'd refer to with like compressing something or compressing an account. You would just like use the input regular account and out comes a compressed account, which is sort of like this hash in a Merkle tree in the end, right? if that is a token account that you're compressing, then the funds would be sort of locked up in this. Essentially, you could call it like an L1 bridge contract. It's not really a different thing. It's just that it's on the L1 and so like not the trust assumptions of like a bridge, cross-chain bridge, like I don't know, wormhole. But essentially, what you're doing is like you're escrowing your funds, and in exchange for the escrow, you're creating this sort of like Merkle tree representation. And the compressed token program that we've built is sort of just mirroring the layout of the SPL token, and so it's compatible with that. And so you can escrow and release. The Merkle tree representation gets created or spent, and you can sort of like compress and decompress back and forth that way.
So I'm going to switch gears because I realize we haven't actually talked about this. How is ZK used specifically in ZK compression?
There's a lot of confusion about this for sure. And there's many good points as well. So what we're using at the tech stack is we're using a snark, to commonly referred to or, commonly referenced when you talk about zero knowledge proofs. Snark meaning succinct non-argument, non-interactive argument of knowledge. Basically, to break that down, succinct just means short, and that's actually the primary thing that we're using here. We're taking many Merkle proofs, which are quite large, and I'll say why, and we're compressing it down to like a very sort of constant size small proof, 128 bytes. So we're using that succinct as the primary property of the snark. Non-interactive meaning that is actually a very important property that is actually quite powerful. It just means that you have sort of basically constant size verification cost on chain, right? So you don't have like a multi-step process of like the prover and the verifier interacting with each other, but it's just like you put a statement out there. Anyone can verify it, just like it's like a one-way operation. It's like false or true, right? And that's pretty powerful actually, because you don't have to re-execute the actual computation to know that it's right or wrong. And then, basically, so we use snarks for this. Now, there's a lot of nuance in like whether you want to call this ZK or just succinct. There's even a lot of debate on this in the Ethereum space. Meaning, basically a lot of the rollups that are commonly referred to as ZK rollups are not actually using that much the zero knowledge property of it, but more like just the succinctness property of it. Basically validity rollups. And then there's some rollups who do like zero knowledge in the sense of like actually like hiding token balances or something like that, like Aztec, for instance. And those actually in the sort of conversation on Ethereum, you would try to refer to those as like ZK rollups. So there's a lot of this like debate conversation going on. I don't think there's any conclusive outcome out of this really so far. And for us, you could say you could also refer to it as like validity compression. The reason why we're or succinct compression and whatnot. The reason why we're calling it ZK compression is we're basically using this like ZKP snark to compress these Merkle proofs. Previously with the CNFT, so compressed NFT plain compression, if you will, just like plain Merkle proofs. Into a small proof. So we're using a ZKP to compress the compression. And that's why it's called ZK compression. To give a little bit of context about the Merkle proofs, Merkle proof just means that's the, when you have this like hash structure, that's of, and it's like a tree, it's like an upside down tree. I don't know why the software engineers have come up with that upside down tree structure, but it's basically to verify the validity of every single leaf in the tree. You check it against the tree root, which is like the single, end hash that you have on recursively hashing all these leaves together. And to do that, you need the proof path, right? So you need the actual like intermediary node hashes. And and each node hash being 32 bytes. So if you have like a tree of height 25, you'd have like 25 of these intermediary steps. So if you want to verify that those plain Merkle proofs on chain, you'd have to send the whole proof path for each leaf that you want to prove validity of. Leaf meaning, compressed account state that was stored on the ledger. The Solana transaction size limit is like about 1.2 kilobyte, so it's really constrained. So this is how you hit like a lot of these like composability limits really quickly. If you use like plain Merkle proofs, especially if you want to like prove multiple account states or interact with multiple compressed accounts in one transaction. So, the ZKP element or the snark element there is quite important. So you get that down to 128 bytes flat.
Yeah, and you can probably kind of start to see where the terminology gets confusing for why. I mean, I'm sure everybody saw that when we released this. Everybody's like, oh, this is Solana just took a ZK rollup and called it something else, or like a Validium, which, first of all, no. Because like you can kind of, imagine, let's do a thought experiment here. Let's say we did call it a rollup, okay? Okay, so, and then we release as developers, and they're like, oh, okay, how do I bridge to it? It's like, well, it doesn't quite apply. I mean, the bridge, not necessarily for users, right? It's kind of abstract because it's kind of an extension of Solana. Okay, it's like, where's the sequencer? Well, there's not necessarily a sequencer for this one. And then it's like, what are the potential resistance properties? Like, where's the DA? It's like, all this stuff is like not very skeuomorphic because the terminology is extremely Ethereum centric. I mean, like if you go to just ethereum.org and look up what an L2 is, it literally just says it's a scaling solution for batch processing, compute, and transactions off chain. And this is like not even close to that, right? Because Solana compute is cheap. That's like transactions are cheap. Storage is different. And then that's what Ethereum's trying to work towards, actually, with kind of the vertical stuff, the stateless client architecture and stuff. And so I wanted to get a conclusive, let's say, proof of authority here. And so I said to Vitalik, hey, what do you think about this? And his first answer was, this is much more akin to stateless client architecture. And if you look at Twitter, like if you do some sleuthing, Tolly has been calling it that since NFT compression, which is, it's literally, there's stuff, there's data, and then you accumulate that data to kind of construct state. It's a stateless accumulator. So, but like obviously you don't want to call it stateless accumulators or developers because it's like, what the hell is that? So like ZK compression is like, okay, you have N accounts and you have compressed them into one account.
I love that. I think that's a crucial point of context. And I think the issue here was everybody wanted to just reframe this in like a way that they already understand it. Ethereum rollups have been around for a while, and there was like some properties that had some overlap here. And so it was like the natural progression of thought. Like I get why it happened, but yeah, I appreciate you laying it out.
It's like, seeing a bicycle for the first time, or no, seeing a car for the first time where bicycles have already existed, and you're like, hey, this is just a bicycle with four wheels. It's like, well, I mean, I guess it shares some similarities, but if you start from first principles, it's kind of a different thing altogether. It doesn't require manpower, right? So anyways, that's kind of the problem with the, I mean, admittedly, Solana's research community isn't as developed or well-known or really even just focused on as much as Ethereum. And so that maybe leads to some confusions there. But like, make no mistake about it, we work on this thing and we know what rollups are. And if you start from first principles, yeah, they share like some, let's say, similarities, but there's no way that I bet you if I'd called this a rollup, it would have caused, first of all, 10 times the outrage and like 100 times the confusion.
Agreed with that. And so I apologize in advance for this next question, but do you kind of think it's a roll-up for a single program?
What do you find as a rollup, right? Like usually, I guess, typically you would think that a rollup sort of rolls up transactions into one transaction, right? Like off-chain transactions into one transaction. Like I think this batch element is something like quite important for like calling something a rollup. I know there are people and like, really smart people, well-respected people who are working on similar things, and they sort of like also call these like single transaction rollups. But I don't I wouldn't refer to that as like a single transaction rollup. But yeah, that's the defining difference, I would say. It's like every user creates a validity proof and interacts with an on-chain program, and there's a lot of some checks, ownership checks, all happening on chain. And so NDA is on chain, so it's also clearly not a Validium. And so sure, like it's not a rollup. I think what best describes it, especially sort of in the context of Solana, if we can come up with some Solana centric terms as well. I would really call it ZK compression. I think at some point you can also just refer to it as compression. I think that's a more generalized term. But for us, it was like, okay, like what's the defining difference between the CNFTs and this version of compression? Well, it's the SNOC element, so let's call it ZK compression.
Mm-hmm. Yeah, like I think the term rollup has the concept of rolling up inside of it. That's kind of like the point of the name, right? And so we're not actually doing that here, especially with the transactions. The transactions are still regular transactions, right? You just send them to the chain as usual. And by the way, I believe there's a team, it was in a Solana research channel on Ethereum that's doing kind of something relatively similar. And even they didn't call it a rollup. They called it like an L1 plus or something weird. And so, again, the fact that this even needs to be discussed this much kind of shows that the name would not have been proper, because the name is supposed to remove confusion, right? I understand it upsets some people because, I don't know, some weird moral inferiority complex, but like it's not actually like we're trying to help developers build things, and if you tell them build with our rollup, they're going to be like, okay, but this has nothing that a rollup actually is supposed to have, as the way it's been defined for the past 6 years in the industry. So why did you call this a rollup? You just confused me. And we're not interested in that. And like, again, the terminology is derived from Ethereum's, let's say, technical insufficiencies in certain regards. Solana has its own technical insufficiencies that are independent from that. And so you should start from those and then work your way up, instead of trying to retrofit random concepts across different problem sets.
Well said. I think that makes a ton of sense. Swen, Mert, anything else we're missing here? Anything else we need to hit on?
How developers can get started. Go to zkcompression.com and the docs are there.
All of this is open source, by the way, not only the docs. All of the code development is happening completely open source, both for the core protocol, Light protocol, and for the RPC implementation, which is built, the name Photon Indexer. All of this is open source. I think it's Helios Labs/Photon.
Awesome. Well, Swen, thanks a ton for coming on, and congratulations on the success you've been having with the launch of ZK Compression. It's exciting to see Solana finding its own scaling path. Super, super awesome to see, and just love the energy, man. Continue to keep building. And Mert, loved having you as a half co-host, half guest this time around. Cheers, gentlemen. Have a great rest of your day.
Cool. Cheers. It was a pleasure. Thanks.